In section 3.3, we're going to prove that lines are parallel using those special angle pairs that we've been talking about: corresponding angles, alternate interior, alternate exterior, and consecutive interior. And we're going to use those to work backwards and show that lines cut by a transversal are parallel. So starting out with the corresponding angles converse. Now you notice the word converse in here. Remember that with a converse, you're flipping the if and then of a statement. Now, when we started with corresponding angles yesterday, we said if two parallel lines are cut by a transversal, then corresponding angles are congruent. Now today, we flip the if and then, and we say if we see two lines cut by a transversal and corresponding angles are congruent, then those lines have to be parallel. So it reverses the order. We don't know the lines are parallel, but we do know corresponding angles are congruent. Therefore, the lines have to be parallel. So in this picture, these two angles are, these two angles that are marked congruent in the picture, these are corresponding angles, right? So the angles marked congruent are corresponding angles. And if corresponding angles are congruent, then the lines that were cut by the transversal have to be parallel. So that line J has to be parallel to line K because the corresponding angles are congruent. So we're working backwards. If you see corresponding angles being congruent, the lines have to be parallel. And let's use that in some examples. Find the value of x that makes m parallel to n. I want to find x so that m has to be parallel to n. We'll take a look at the two angles that are noted. These are corresponding angles. You know, that same angle shape there. So if I want m to be parallel to n, I need these corresponding angles to be equal, to be congruent. I need that 4x minus 8 to be equal to 52. So I'm going to find x so that that's true. I'm going to add 8 on both sides, so that's gone. 52 plus 8 is 60. I'm going to divide by 4 on both sides, and I find out that x is 15. Let's see here. Example 2, is m parallel to n? Are these two lines parallel? Taking a look at what I'm given, a 75-degree angle here, a 105-degree angle here. Now, I don't know whether they're parallel, but if I can show that corresponding angles are congruent, then those lines have to be parallel. Well, think about what you know about any sort of group of 4 angles when two lines cross. These two are a linear pair, right? No matter what the case is with lines m and m, these two have to add to 180 because they're next to each other on a line. They're a linear pair. If this is 75 degrees, this has to be 105 degrees because these two would have to add to 180. Now, these angles are both 105. This angle 105 off of line m, this angle 105 off of line n, both off that transversal. Corresponding angles are congruent. Therefore, the lines are parallel. So I'd say yes, and if you needed a reason, you would say corresponding angles converse. Remember, it's a converse because we're showing the lines are parallel from having congruent angles. Okay, but first I guess I would have to say I knew this was 105 from the linear pair. Now, corresponding angles converse isn't the only converse we can have. We can talk about alternate interior angles. If we know that alternate interior angles are congruent, then the two lines cut by the transversal would have to be parallel. If we know that two alternate or both alternate exterior angle pairs are congruent, then we know the lines cut by a transversal are parallel as well. This one's a little different. Remember, consecutive interior angles. If we would know that these are supplementary, then the lines cut by the transversal are parallel. Notice again that all of these are the converse because we're starting with knowing the angles are congruent and we're saying the lines are parallel. If we know alternate exterior angles are congruent, then the lines are parallel. Alternate exterior angles converse, and consecutive interior angles converse. So we can use any of these today, knowing any of these angle pairs are congruent or corresponding, or knowing these are supplementary. We can say that lines are parallel using these converses. Let's practice using those here. Decide, are lines A and B parallel? Alright, I see that there are two angles marked congruent. If these are a special angle pair, I can use one of the converses I just talked about. And I notice these are opposite outside angles. These are alternate exterior angles, and they're congruent. So yes, we do know that lines A and B are parallel. A is parallel to B, and that would be because those are alternate exterior angles. Converse would allow us to say that. Whoops. I'm starting to write converse, but I need to say it's the it's by alternate exterior angles converse, because that's the type of angle pair that we see are marked congruent. Therefore, our lines A and B have to be parallel. And make sure you're writing that word converse in there, because it's saying we start with alternate exterior angles congruent, and we're saying the lines are parallel. Alright. What about here? Are lines A and B parallel? Well, I see two angles marked congruent. What kind of angles are these? I have this transversal, my two maybe parallel lines. These are corresponding angles. This is the very first one we talked about today. These corresponding angles are marked congruent. So yes, A would have to be parallel to B since corresponding angles are congruent. That is the corresponding angles converse. If there's a pair of corresponding angles marked congruent, then the lines have to be parallel. Again, making sure we use that word converse. And finally, our lines A and B parallel here. I see two congruent angles marked. What kind of angles are these? Well, they're opposite and in the inside or interior. These are alternate interior angles, and they're congruent. So yes, A would have to be parallel to B by the alternate interior angles converse. So start getting used to using that word converse when you're proving that lines are parallel from congruent angles. Remember, you're not going to use converse when you know lines are parallel and you're listing congruent angles. And we're going to use both in this proof, actually, a converse and a regular one. Oh, sorry, in a later proof this chapter. What I'm going to do in this example is actually prove the alternate interior angles converse. Now that was a theorem, which means it's something that can be proved. The only thing that I can actually use is corresponding angles converse. So this is saying the only thing I can use is if I know corresponding angles are congruent, then I can say the lines are parallel. So to prove that these lines G and H are parallel, I have to get these angles congruent, then I can say that G is parallel to H. So I need a pair of corresponding angles congruent. And you notice, actually, I am given that angle 1 is congruent to angle 2. Which makes sense, because if I'm proving alternate interior angles converse, these are alternate interior angles. I'm proving that when they are congruent as they are, that these lines have to be parallel. So if alternate interior angles are congruent, are G and H really parallel? That's what alternate interior angles converse said. Now, in order for us to do that, I'm going to have to get corresponding angles to be congruent, because that's the only one I can use. Do you see an angle in here that I could label as angle 3? That would be a corresponding angle with one of these angles, but also that I would know was congruent because it's a special angle pair with another. And there's two possible angles you could label as angle 3. I could label this as angle 3 because it's a corresponding angle with which one? Angle 2. But I know that 3 is going to be congruent to 2 because 1 and 3 are what types of angles? Vertical angles, and they have to be congruent. Then 3 and 2 will be congruent and we'll be good to go. The other angle we could label as 3 would be right here, because this angle would be corresponding with 1 and vertical angles with 2. So either of those would work. I'm going to set up this proof here. So we'll do our statements and reasons, another 2-column proof today. We're going to look at a new type of proof tomorrow. We always start with what we're given. We were given that angle 1 was congruent to angle 2. Remember, I'm trying to prove that these lines, G and H, are parallel. So I have to get some corresponding angles congruent. Alright, we're given angle 1 and 2 are congruent. Now that I labeled angle 3, can you tell me which angles I know are congruent? Well, I know angle 1 has to be congruent to angle 3. And how do I know that? What kind of angles are 1 and 3? They're vertical angles. And again, technically it's vertical angles congruence theorem. I'm fine with just vertical angles. Now remember how we have to get corresponding angles to be congruent? Then I could say the lines are parallel? Well, if I know that 1 and 3 are congruent, I could basically put that arc here now too. I need to show that these corresponding angles are congruent, 3 and 2. Are they? Well, look at the previous two statements. Angle 1 was congruent to angle 2. Angle 1 was also congruent to angle 3. Therefore, angles 2 and 3 have to be congruent because they were both congruent to angle 1. They're both congruent to the same thing. Now, there's two reasons you could give for this. If two things are congruent to the same thing, they're congruent to each other, you could write transitive property. In this case, it's a transitive property of congruency, since we're using congruent signs. Or, since things are congruent to each other, instead of angle 1 right here, I'm putting what angle 1 is congruent to, which is angle 3, and you're substituting in doing that. So either of these would be okay reasons there. And now, angles 2 and 3 were corresponding angles. Therefore, since 2 and 3 are congruent and they're corresponding angles, G has to be parallel to H. Because I have corresponding angles congruent, the lines are parallel. That was the very first theorem we looked at today, which was corresponding angles converse. Remember, it's the converse if you are proving lines parallel from congruent angles. So, cool. We started with alternate interior angles congruent. We were trying to prove, yes, the lines have to be parallel. We did that by listing a vertical angle, showing that corresponding angles were congruent, therefore the lines have to be parallel. Corresponding angles converse.